Too hot to handle. Our phone's in the heat. We've all been there. You're scrolling through your phone on a sunny day and suddenly it freezes. Or maybe it just gets sluggish, the battery draining before your eyes. This is your phone's way of saying, I'm too hot. Overheating is a common problem for electronic devices, especially smartphones. These pocket computers pack incredible power into a tiny space, but that power generates heat. When your phone gets too hot, it can lead to all sorts of problems. Performance can slow to a crawl, apps might crash, and in extreme cases, your phone might even shut down completely to protect itself. These issues are more than just annoying. They highlight the delicate balance between performance and temperature in our devices. While we might not give it much thought, the temperature of our devices plays a crucial role in their functionality. Understanding why heat causes these problems requires a peek inside the phone, where tiny components are working tirelessly to keep us connected. Silicon on the struggle bus. Heat and semiconductors. At the heart of every smartphone lies a tiny marvel of engineering, the microprocessor. This chip, made primarily of silicon, is essentially the phone's brain, responsible for everything from running apps to connecting to the internet. These semiconductors, as they're called, are incredibly sensitive to temperature. Think of it like this. Imagine a busy highway with cars representing electrical signals. At normal temperatures, traffic flows smoothly, but as the temperature rises, it's like the road itself starts to melt and warp. The cars or electrical signals have a harder time getting through, leading to slowdowns and errors. This is essentially what happens inside your phone when it overheats. The smooth flow of electrical signals is disrupted, leading to reduced performance. This phenomenon is known as thermal noise, and it's a fundamental challenge in electronics design. Thermal expansion and contraction, a material world. The problems caused by heat aren't limited to semiconductors. Every material expands and contracts with temperature changes, and this constant shifting can take a toll on the delicate components inside your phone. Imagine a bridge constantly expanding and contracting in the heat and cold. Over time, this movement would weaken the structure, potentially leading to cracks and instability. The same principle applies to your phone. The various materials used in its construction, from the metal frame to the glass screen, all have different rates of thermal expansion. As the phone heats up and cools down, these components are constantly pushing and pulling against each other. This constant stress can lead to a number of problems, including weakened solder joints, cracked circuit boards, and even battery damage. While manufacturers take steps to mitigate these issues, the cycle of heating and cooling remains a challenge for device longevity. Thankfully, our phones aren't completely defenseless against the heat. Modern smartphones are equipped with sophisticated systems designed to prevent catastrophic overheating. One of the most common methods is known as throttling. Think of it like a car's engine control unit, which reduces power to the engine to prevent damage when it gets too hot. When your phone's temperature rises too high, the processor automatically reduces its clock speed, essentially slowing down its operations to generate less heat. This might result in slower performance, but it's a small price to pay to prevent permanent damage. In extreme cases, your phone might even shut down completely as a last resort to protect itself. While this can be frustrating, it's a clear sign that the phone's internal temperature has reached a critical level. These safety mechanisms are a testament to the engineering ingenuity that goes into designing these devices. The battle against heat is an ongoing challenge in the world of electronics. As devices become more powerful and compact, heat dissipation becomes even more critical. Engineers are constantly working on innovative solutions to keep our devices cool and running smoothly. One promising area of research involves developing new materials with better thermal properties. For example, graphene, a single layer of carbon atoms arranged in a hexagonal lattice, is an excellent conductor of heat. Incorporating materials like graphene into device design could lead to significant improvements in heat dissipation. Another approach is to rethink the way we design our devices. Instead of packing components tightly together, engineers are exploring more distributed layouts that allow for better airflow and heat dissipation. These advancements highlight the constant innovation happening behind the scenes to push the limits of technology. While engineers continue to innovate, we can also play a part in keeping our devices cool. Simple steps like avoiding direct sunlight, Removing bulky cases in hot weather and closing unused apps can make a noticeable difference. It's also important to be mindful of how we use our phones. Demanding tasks like gaming or streaming video put a heavy load on the processor, generating more heat. Taking breaks during these activities can help prevent your phone from overheating. By understanding the challenges posed by heat and taking simple precautions, we can help our devices perform their best and prolong their lifespan. After all, a cool phone is a happy phone, and that's something we can all appreciate.